All right, today we are going to be learning about how to do scatter plots, how to perform both linear and quadratic regression, even though the title is quadratic regression, as well as a couple other functions in your graphing calculator. So you need to be turned to page 167. You should also have out these calculator notes. Just in case you get behind, you can pause the video and then kind of look at where I am. These are written out are general steps, meaning that when we're not doing problems in this particular section, this should still help you remember to find a scatter plot, how to do regression, how to find a value, and how to find zeros. So you want both of those things out. You also need your graphing calculator because we're going to be using it here momentarily. So at the top of your section, it says a model rocketry club placed an altimeter, I'm not sure how to say that, on one of its rockets. What that does is it measures the altitude or the height of an object above the ground. The table shows the data the club members collected from the altimeter before it stopped transmitting a little over 9 seconds after launch. So in your book, I believe that the table is listed horizontally. Here it's vertically, but it's the same data. So you've got time since launch. Again, it stopped transmitting after 9 seconds. So it's got the first 9 seconds and then what the heights were at those various points. So the first thing that it wants you to do there, number 1, is to predict the height of the rocket 12 seconds after launch, and then explain how you made your prediction. So just take 1 minute. You can pause the video here if you need to. Take 1 minute to go ahead and make a prediction and explain why you thought what you thought. All right, so hopefully you've got your prediction there. Certainly your predictions and explanations will vary. Later in the lesson, we'll come back and look at what is the exact height of the rocket after 12 seconds. So next, in number 2, it wants you to make a scatter plot of the data on the coordinate grid. Remember that a scatter plot is just points. You're not connecting them at all. It's just the points. So what you want to do here in this grid that's provided to you is you want to go ahead and plot each of the ordered pairs. So 0, 0, 1, 54, 2, 179. Again, please go ahead and pause the video here for just a minute or so to give yourself time to get that plotted on your coordinate plane there. All right, so hopefully your dots look something like this once you've made your scatter plot. So the next thing that we're going to do is we are going to learn how to do a scatter plot in your graphing calculator. So the steps that I have on this are just a little bit different than what your book says in number 3. So we're going to be following this, and I'm actually going to do this. I'm going to bring my on-screen graphing calculator on so you can kind of follow along. Again, please pause the recording as needed to make sure that you can keep up with what we're doing. So the first thing that you're going to do when you want to make a scatter plot is that you need to go in by pressing second, so button right here, and then press your Y equals because that's your stat plot button. And you need to choose one of your 3 plots. If you don't have anything you need in plot 1, I would choose plot 1. So press 1, and that will choose the first plot. So now we need to deal with what's in here. So I need to turn the plot on by pressing enter over top of the on. You want your type to be listed as this first type. So if you scroll down, you want this one to be darkened. So if, for instance, yours looked like this, where it had the second one darkened, you would just scroll over to the first one and press enter to switch it to that. You want your X list to say L1. Now mine already does, but if yours doesn't, the way you get it to say L1, see in blue here above my 1 key it says L1. If you have an older calculator, it might be in yellow. But regardless, you choose or name a list by pressing second and then pressing the list number, so list 1. Then make sure that your Y list says L2, same thing. If it doesn't, you can press second 2 and make it say L2. On the mark, you want it to be the first one, which is kind of that big square there. If you have an older model, it doesn't have a color choice here. If you want to change the color of your scatter plot, you can if you have a newer model. Blue is fine for me. So once you have done all of that and your screen matches mine right here, then you can go ahead and press second quit to exit out of that screen. So now we've got our plot turned on. So now we need to actually enter our data. In order to enter the data, you're going to press Stat, and then you're going to choose choice 1, which is edit. And it's going to bring up your lists here. Now, I have already entered the data in here. When you are entering the data, if you're in L1, it moves down the different lists. So you can enter it quickly by just pressing the first bit of data and then enter, and then the second one, and then enter, and then third, enter. So 0, enter, 1, enter, 2, enter, 3, enter, so on and so forth as you scroll down. That's a little bit quicker than using the arrows. Certainly if you make a mistake, use the arrows to go back up and fix it. So if, for instance, I had accidentally hit 44 here instead of 4, I could scroll up, press 4 again, and press enter to fix it. You always, when you finish entering, want to double check your lists. So in L1, it's important that they're in the right order. L1 should contain your X data, which in this case is time, because in our stat plot screen, we said that our X list was L1. So make sure that your time data is in L1 and your height data is in L2. Again, double check all of the values. Sometimes people accidentally hit one value twice and skip one. Obviously, it's going to make a huge difference in your equation if your data isn't entered correctly. So make sure your data is entered correctly. Again, if you need to pause the video here to get that in, you can. If you've got it, great, continue. Once all of your data is entered, we are going to press zoom, and then you're going to choose choice 9. We just did stat entering. Zoom stat gives you a window that at least can see all of your data points. Now, this isn't going to end up being our final window, probably, but this gives us a good place to start, a much better place than Zoom 6 would for a standard window. So whenever you're doing a scatter plot, you should start your window by pressing Zoom and then choice 9. So Zoom 9 will get you at least a good starting place for your scatter plot. So you notice, hopefully this looks something like this, which mine does. Again, if yours doesn't, then go ahead and check your data by going to Stat Edit again and making sure that you didn't make a mistake on one of your data entry points. All right, so if you couldn't see some of the plot, then you could manually adjust your window. You see where it is here. It went from -0.9 to 9.9, so you might even change that, -1 to 10, something like that if you wanted. Again, we could see it pretty well, so for right now it's okay. I also, on your handout, put a helpful hint. First of all, when you're doing your homework, you probably don't want to delete your lists. You probably want to use multiple stat plots, just not all at the same time. So if you go to second stat plot, you can see here right now all I have turned on is plot 1. You can turn plot 1 off and still keep it list 1, list 2. Let's say that you want to do the first homework problem in plot 1 and you want to do the second homework problem in plot 2. You can do that by, you would turn on plot 2 and turn off plot 1 when you got to number 2, but you would also have to change your lists. So you might make this one list 3 and list 4, for instance, and I made it a different color. This is a way that if you make a mistake, I can actually check your calculator. Obviously, if you've deleted all the data, there's really nothing I can do to figure out what you did wrong. So again, that's just a way that you can kind of keep data if you need to, in case you mess something up. Also, the helpful hint I put there, if you want to clear an entire list of data, so let's say you're positive that you got the first set of data and answer right, and you don't need list 1 and list 2 anymore, you could go to Stat, press 4 for clear list, and then tell it which list to clear. So I could do second L1, comma, L2. Don't actually press enter because we don't want to clear that data right now. But if you pressed enter, it would clear those lists. It would say done for you. All right. So we've entered the rocket data into our graphing calculator like number 3 said. We entered the time data, the height data. It says, then use the calculator to perform a linear regression on the data. Write the equation of the linear model that results from the regression. So in order to do that, we need to perform regression, which is the second thing on your handout. Again, I'm going to go through it here with you as well. Feel free to pause as needed. So we've already done number 1. Our data is entered in our L1 and L2. So next we're going to press Stat, and we're going to scroll right to highlight the Calc menu. In the Calc menu, right now it's asking us to perform a linear regression. So that's choice 4, so I'm going to hit 4. Then if you have a newer calculator like this one, it brings up this menu where it says X list, Y list. If you have an older calculator, it's just going to go back to the home screen and it's going to say linreg, and then it might have a parenthesis, it might not, it might just say linreg. Either way, whichever model you have, the next thing you have to do is tell it what your X and Y lists are. So we had put our X list in L1 and our Y list in L2. Obviously, if they don't say that right now, then you need to change it. Again, you can name the list by pressing second and then whatever list number it is. So if you have the older model, you will have to manually enter this every time. So on your home screen, it says linreg. Go ahead and hit second 1 to get L1, and then hit comma, and then hit second L2. And don't do anything else. Just leave it L1, comma L2 after the linreg. Again, that's only if you have the old model. If you have the new one, make it look like this. We skip frequency list. We don't ever use that one. The next thing we're going to do is tell our calculator where to store the regression equation. If you have the newer model, you just scroll down to here to do it. If you have the older model, put another comma in after your L2. So it should read L1, comma, L2, comma. And now you're going to do the same thing that I'm doing here. This is listed under number 5 on your handout. We're going to tell the calculators to store the regression equation into a spot on our y equals screen so that we don't have to type it in by hand, and also so that we don't have to round it. We get a more exact value. So under store regression equation, we're going to hit vars. Then we're going to scroll right for y vars. That's variables is what vars is. So we want y variables. We're dealing with functions here, so we choose choice 1. And then you choose where you want it to paste the regression equation into. So unless you have something you want to keep in your y equals screen, you can go ahead and choose y1. So if you have the newer model, it should now say y1 here. If you have the older model, you should still be on the home screen and it should say L1, comma, L2, comma, Y1. If you have this newer model, scroll down to calculate and press enter. If you have the older model, you can go ahead and just press enter. It should then tell you what the model for your regression equation is. Since this is linear regression, we've got ax plus b, and then it tells you your value for a and your value for b. So in number 3, it asked us to write the equation and to round our coefficients and constants to the nearest tenth. So in 3, in your book on page 168, you should type in 41.4x, because the a goes in front of the x, and then plus 71.4. So that is our linear regression equation. Number 4 says use a dashed line to graph the linear model from item 3 on the coordinate grid showing the rocket data. So if you press graph in your graphing calculator, it will show you the line. And again, if you do second graph, you can get actual values to plot, which will help you then to plot it into your book. So you're going to go back to your book. You can look at second table, look at the graph, and it's got all the values for you to create a good looking line there in your actual book graph. So once you've done that, it should look something like this. Again, feel free to pause here to take a minute so that you can actually get a good looking graph on here. All right, so in 5A, it asks, to the nearest meter, what height does the linear model predict for the rocket 12 seconds after it is launched? So what you want to do here is, and I'm going to show you an alternate way to find this answer here in a second, but what this means is to plug in 12 for your x. So you can do number 5 by hand and just plug in 12 here if you want. What you can also do is, if you flip your calculator handout to the back, I have instructions for how to find a specific value for an equation that you graphed. So plugging it in by hand, which is what I want you to write out in number 5. So write out 41.4 parenthesis 12 plus 71.4 and come up with your answer. And then I'm also here going to show you how to do that on the graphing calculator. So once you've got it graphed, first of all, it says step 1, make sure that your window includes and goes a little past the value that you want it to find. So right now my window only goes up to 10. If I want to find when x is 12, my window needs to go past 12. So I'm going to change this and I'm going to make it 15. As long as it's at least 13, it should be fine. But I just changed my window there because the calculator will not find a value if it can't see it. Now also, notice that the y value, you can't see where x is 12. You can't see the y value either. So I'm going to adjust my y max and I'm going to make it bigger. I'm going to make it, let's say, 600. Oops, not 6,000, 600, delete. And press graph again, because again, in order for this feature to work in your graphing calculator, you have to have your window so that you can actually see that point. So if this one's 10, 11, 12, yes, my 12 value is going to be on here. So once that's done, you can go to step 2 on the back. It says press second and then trace, and we're going to be choosing choice 1 value. And then notice it gives you this blinky guy. You just press in whatever value you want. So 12, enter, and then it should pop up a value here. Hopefully that's pretty close to the value you got by plugging in 12. This one is a better answer because it didn't round the original equation. It's an exact value. Now this is rounded. but the equation itself was exact. So gives you 567.8, which is about 568 meters. So that's your answer for number 5 is 568 meters. So now you can look at back to item 1 and see how that value compared with what you predicted. If you predicted like a linear model, meaning that it was going to keep going up, it was probably pretty similar to this. However, if we look at number 6, it asks us to decide if we think a linear model is a good model for the rocket data and to justify our answer. Some of you may have thought of this already in number 1. Some of you may not have, and that's okay. But if you look at the scatter plot, this data is starting to go back down, and it's a rocket. A model rocket is not going to continue going up forever and ever and ever. It's going to go up, hit a max, and then come back down. So no for number 6, because a linear model is not a good model. A linear model indicates that the rocket was already about 71 meters off the ground when it was launched, which isn't true. It was 0. And it would indicate that the rocket's height would continue to increase with the time without the rocket ever landing. So this isn't true because the rocket's height starts to go down. If you look at your chart, after 8 seconds, it's no longer going up. It's now coming back down. It's even below where it was at 7 seconds. So a linear model is not a good model here. So then it says a linear regression is the process of finding a linear function that best fits data. A quadratic regression finds a quadratic function, so a parabola of best fit instead of a line of best fit. So 7 has some steps typed out for you. Again, if you look back at the front of the handout I gave you, it has steps for quad regression there as well. So now what we're going to do is we're going to go ahead and we're going to perform a quadratic regression on our data here. So if you go back to your calculator, you can press second quit to get out of this screen. Again, our data is already entered, which is step 1. So now we're going to go back to this stat. We're going to scroll to calc again. But this time we're going to choose choice 5, which is quadratic regression. Again, if you have the older model, you're just going to type L1, L2, Here you're going to say L1 and L2 in your X and Y list. Then we need to tell it where we want it to store our regression equation. We don't need to keep our linear regression equation anymore because we already used it. But there will be cases where you want to. So just in case, you might want to store this regression equation in your Y2, because if you store it in your Y1, then it's going to overwrite the linear one that you already had. So now, again, if you're on the older model, you've got L1, L2, and then you press these buttons, vars, Y vars, choice 1 for function, and again, I'm going to choose my Y2 this time. Once you've got L1, L2, Y2 in the old version, or you've got this in the new one, scroll down to calculate or press enter to calculate. And then it again gives you the format, ax squared plus bx plus c. And it tells you your values for A, for B, and for C. So this is what we want to use to answer number 7 in our book, where we're going to write this equation. Again, all we're doing is looking at the calculator and rounding these values to the nearest tenth. So negative 6.9, 103.8, negative 11.8, and that's what we used here to come up with this quadratic equation. So now it says graph the quadratic model from item 7 on the coordinate grid showing the rocket data. So again, it's much easier to use your graphing calculator here to come up with this. So if we go to our graphing calculator, again, we pasted the regression equation already into our y equals. You can see there that it already did it for us. So we can go ahead and press graph. And it's still graphing the line because we didn't delete it. Again, you can delete it if you want to. But now it's also graphing in red our y2, our quadratic model here. And if you go to second graph, you see in red our y2, those are the y values that go with the x values here. So an ordered pair would be 2, 168.05, 11, and then this 290.56. So you can use that. Again, pause the video if you need to here in order to get this on your graph back on your original space on page 167. Once you've got that graphed, it says to contrast the linear model with the graph of the quadratic model, which is a better fit. So obviously the contrast, the quadratic model starts at 0, the linear model starts at 70-ish. The quadratic model goes up and then comes back down, whereas the linear model increases infinitely. The quadratic model is better because that shows that the rocket will eventually return to ground level. So that's your answer for number 9 here. Number 10 says to the nearest meter, what height does the quadratic model predict for the rocket 12 seconds after it's launched? Again, you can do this by hand. If you plug in 12 to this, your answer from number 7, and use your calculator, you can come up with an answer. It's usually just as easy to do linear by hand as on the calculator, but quadratic, it's easier to use the calculator because you don't have to do all the steps of typing all of that in. So if we want to do that on the calculator and find the answer, it says prediction should be close to 240 meters. So let's test that. So we go to our calculator. And I'm going to go to my y equals, and I'm just going to turn off the linear right now because I don't want it to confuse the calculator at all. So once I've got it graphed, I'm going to be doing the same steps that I taught you here in number 5. Again, the typed out directions are on the back of your handout. You're going to press second trace, choose choice 1, and then type in 12 and hit enter. So it tells you y equals 234.78. So we would round that to 235. So yes, that prediction is close to 240. This prediction is better than 240. It's more accurate because the one you would get by hand, you rounded to the nearest tenth. Here your calculator is using lots of decimal places. So this answer is better. 234 meters is the approximate height after 12 seconds. How does that value compare with the prediction you made in item 1? Again, your answer is going to vary there depending on if in item 1 you realized that it was quadratic or if you thought it was linear. Last thing here for today. It says use the quadratic model to predict when the rocket will hit the ground. Explain how you determined your answer. Well, it hits the ground over here. This is its starting point, so that's not when it hits the ground. This is when it hits the ground. So I want to find that exact value. If you press trace, you can get it to your cursor to move and you can come up with a close value, but we don't want close, we want exact. And so you can scroll over here and again you can get it close and it'll say, well, you know, that's pretty close. It looks like it's somewhere around 15 seconds, but we want to be sure. We want to have an exact value. So the very last thing on your handout, on the back, it says to find a 0, which is the same thing as an x-intercept. So It hits the ground at this second x-intercept. Step 1 on that handout here tells you to make sure that your y-axis goes a little below 0. If it doesn't, adjust the y-min, and that you can see all of the zeros on the x-axis. So adjust the x-min and max if not. So here I can see it, but just barely. So I'm going to make my x-max a little bit bigger than what I have right now on my window. So I'm going to just move my x-max to, let's say, 18. So that it makes sure to fit. It does, my current window does go a little below 0, so I was good on that. If yours didn't, you would make your y-min something a little below 0. So that's step 1. Step 2 says press second trace and choose choice 2, 0. Again, this is how you find x-intercepts. Zeros and intercepts are the same thing. Your calculator is asking left bound question mark. It's telling you to move your little blinking cursor so that it's at an x value that's just to the left of the 0 you want to find. And I've done screenshots there for both of your zeros just because, not in this case, but in other cases, you're interested in finding both intercepts. Here we only care about the right one. So left bound of this x-intercept means an x value just to the left. So I've got my blinking cursor just to the left. I tell my calculator that I did it by pressing enter. In the newer models, it gives you a nice line. Older ones, it just does this little triangle. So it shows you a line showing, yes, indeed, that is to the left of this intercept. And then it says right bound question mark. So you move your blinking cursor to an x value that's to the right of your intercept there. So this one is to the right. So then I tell it I did that by pressing enter. Notice that it puts a second line or a second triangle in. Your intercept should be between those lines or between those triangles. If it isn't, then go back and do your left bound, right bound again. Now it's asking, do you want me to guess? Tell it yes by pressing enter. So notice it has found the 0. It says x equals 14.846686. And I explained this whole 3e to the negative 11 thing in writing on your handout. That means the same thing as 0. It's essentially 0. Your calculator, of course, is rounding, so it's getting really exact, but that is 0. So the x value is 14.846686. So it says predict when the rocket will hit the ground. So you should write as your answer to number 11, the rocket will hit the ground after approximately 14.8 or 0.85, depending on what you round to, because it didn't say here, seconds. All right. So that wraps up how to perform quadratic regression. Again, this handout has everything with screenshots and typed out in words. So if you get stuck in your homework, you can always refer to that. You can also, I have this video linked on the website. So if you need to watch it again and go through it, certainly you can do that as well. But that's it for now.